Hello everyone. So this is Mahavir sir from Mahavir Jain Academy is here as promised that we are going to conduct all the lab activities from the chapter acid, bases and salts. So listen carefully. So hope you will going to enjoy this session. So first let us start with the litmus paper. So you should know how the litmus paper looks like. So this is the red litmus paper, how it looks like, and here we have the blue litmus paper. This is how it looks like, and we have the pH scale over here, and we have universal indicator, yes, and methyl orange is there, and also we do have the phenolphthalein. So we are going to test the solution which is given over here. Some solutions are there in a petri dish, and also some are there in the test tube over here. You can see it. So we are going to test for the nature of the solution, whether it is acidic or basic in nature. So first thing is I am going to take the red litmus paper and dip it inside this solution, and as we all know that if this is a base, its color will change into blue in color. So let us dip inside this solution. Yes, so you can see there is no change in color. That means this solution, we cannot tell now whether it is acid or base because we have one more solution. So we will test in that particular solution also. Let me take another litmus paper over here, and you can see here closely that I am dipping into this solution. Now what is happening to this pH paper? The red litmus paper is changing into blue color. That means it indicates that this solution is basic in nature. Similarly, we will take another litmus paper, that is the blue litmus paper. So if I dip this blue litmus paper in this solution, definitely its color will not change because already we have known that this is a basic solution. But if I take the same litmus paper, dip in this solution, if it is acidic in nature, that means its color will change into red color. You can see there clearly that there is a change in color of the blue litmus paper to red color. This indicates this solution is acidic in nature. Hope it is clear. Now, already you have studied in the class about the universal indicator, so-called pH scale and all. The scale will be not too long and all. So this is how the scale looks like. You can see here there are values from 0 to 7, and this side we have from 7 to 14. Different colors are there. Already you have studied in your regular theoretical classes and all. And this is how the pH paper will looks like. I think so many of the schools and all, they will not conduct this lab activities. So you can see here, this is the color of the pH paper, kind of orange cream and all. So we know the color change, how the color changes will happen, and what are the color changes happen in any type of solution, we need to match with the pH scale. The color of the pH scale we need to match and tell what is the pH value of this one. So I am going to dip this particular. Now I have taken the pH paper. I am going to dip inside this solution. So they ask you to test what is the pH value of this solution. When you dip inside, you can see the color of the pH paper is dark blue in color, and when you take the pH scale and match inside, here the colors are not matching, and when you go here, it is matching with the pH value of 14. The color is matching. Then we will tell this solution what you have taken, it is what? Strong base. Okay. Similarly, if I take another pH paper and dip in another solution, let us try to see the change in the color. Now see here, I am taking this paper and dipping it inside this solution. Now you can see it changing into dark purple red color, and let us match this color with the pH scale. It's matching with the pH value of 1. So 1 means what? It is a strong acid. This solution is strong acid. So pH scale majorly meant for testing this solution, whether it is a strong base or weak base, or strong acid or weak acid, or mild acid or mild base. By change in the color, we match with the pH value, and we will tell the value of that pH of the solution. Now we have the universal indicator. So these indicators are generally made up by mixture of the several indicators. Then let us put in one of the solution over here. So universal indicator, and here you can see clearly there are the different colors of the universal indicator, and they are given the respective pH value, and we are going to match this change in the color with the the color of the pH values which are mentioned in the indicator. So let me put it inside the units indicator into this solution, and you can see clearly here it is showing the red color, and when we match it is coming around pH value of 1, that indicates it is a strong acid. Similarly, I will take the another solution over here, and I am going to add the universal indicator into this particular test tube containing the solution, and it is showing the blue color. When I match this blue color, it's around pH value 9 or 10 it is showing. That means it is a strong base. So hope this is clear about the universal indicator. Next one, we are going to take the synthetic indicator. Two synthetic indicators are there as mentioned in the NCERT. One is the methyl orange, which is orange in color. Another one is phenolphthalein. Always it will be colorless in it. Okay. So as we all know that methyl orange, when it comes in contact with the acid, its color will change into red color. When some come in contact with the base, it will change its color to yellow. So let us try with these solutions, mixing the orange color, methyl orange, into the test tube, and you can see its color is changing to red color. That indicates that this is a acid. But when the methyl orange comes in contact with the base, as we studied that, it will change its color to yellow. How it will change? Let us try to understand over here. You can see clearly there is a change in color, yellow color. That means that this is the base. Hope this is clear. So next one, another synthetic indicator is the phenolphthalein. Phenolphthalein, when it comes in contact with the acid, we studied that it will become colorless. Let us put this solution into the acid. Definitely it remains colorless. You can see here clearly. It is colorless only. There is no change in the color. That means this solution is acidic in nature. But what is studied, when it comes in contact with the base, it color changes into purple pink. So let us try whether its color changes in purple pink or not. You can see here clearly it is changing its color to purple pink. So hope this is clear. This is very really interesting. Okay, because in so many schools they don't conduct the lab activities and all. And now I think so all your doubts are clear with the indicators, universal indicator, litmus paper, and all those things. So next one is really interesting. That is this diagram is really important. Why this diagram? Every year, if you see, this diagram is being repeatedly asked. What is that? Popson diagram, or liberation of the hydrogen gas, or we call it as reaction of the zinc with the HCl. So all the metals, when they react with the any acid, they liberate one particular gas, hydrogen gas. How do you test for the hydrogen gas? When the gas is liberated, we hold the fire and it will give the pop sound. Okay, so I already see this is setup of the reaction of zinc with the HCl acid. Now, so this is the test tube and this is the core, and you remember most of the time they'll ask the labeling for dilute. This is how the dilute tube looks like, and we have taken the soap solution over here, and whatever the gas is liberated, hydrogen gas, we are going to pass it into the soap solution. Definitely it will produce the bubbles of hydrogen gas, and when we hold the fire, then definitely it is going to give the pop sound. Let us try that. So I am just taking out this cork and putting the zinc granules inside the HCl. Already we have taken the HCl, you can see there clearly, and I am adding it here. So the reaction has been started, and there is the liberation of the, you can see clearly, hydrogen gas, and we are going to test. You can see here clearly the bubbles of hydrogen gases are being produced inside the soap solution, and after that we need to hold the fire near the bubbles, and if it is giving pop sound, that means that gas liberated is the hydrogen gas. So but make sure that when you are testing for the hydrogen gas, please keep away the soap solution beaker away from the HCl, because HCl is highly volatile, it will catch fire. So I am keeping it in front and I am trying to hold the fire to the soap solution. You can see the pop sound, clear pop sound. Because why it give the pop sound? Because hydrogen is a fuel. If more amount of hydrogen fuel is there, it would have blasted. but less molecules of hydrogen gas will produce pop sound, but we do not use the hydrogen gas for the domestic purpose as it is highly volatile in nature. Hope this is clear. The next one is you can see the page number 20, that is reaction of the HCl into H2SO4 into sodium carbonate will liberate the carbon dioxide gas. Any carbonate compound, when they are reacting with the acid, definitely they'll ask 1 mark question and all, that gas liberated will be always carbon dioxide. Now today we are going to test whether the gas liberated is the carbon dioxide or not by passing that carbon dioxide gas into the lime water. So as I told you earlier that the conical flask inside we can see the sodium carbonate is taken, and we are going to add the H2SO4 into this. So whenever any metal carbonate react with the acid, it will liberate carbon dioxide. So how will come to know the liberated gas is carbon dioxide or not? We pass that carbon dioxide into the lime water, it will form the white precipitate. So let us try that. So there's a conical flask, rubber cork is there, delivery tube is there, and this is how the thistle funnel looks like, where we add the acid into it. So I'm going to add the which acid? H2SO4, and what is there inside the conical flask? Sodium carbonate is there. You can see that I'm adding the acid into that, and the reaction has been started, and we need to take the lime water and close this thistle funnel to make sure that the carbon dioxide will not escape in any of the way. And here you can see the clear liberation of the carbon dioxide into the lime water, that is calcium hydroxide. Earlier it was colorless, now you can see the color is changing into white, or milkiness is appearing, or the white precipitate of calcium carbonate formation is there. So let me take out this lime water. You can see there clearly there is a formation of white precipitate of what? Calcium carbonate. One more interesting thing, question what they'll ask over here is, after formation of calcium carbonate, again if you pass excess amount of carbon dioxide, this particular calcium carbonate will react with the carbon dioxide and it will form calcium hydrogen carbonate. That calcium hydrogen carbonate is soluble in water. This milkiness will disappear. Hope this is clear. So the next one is conduction of electricity. As we all know that acids and bases behave as a good electrolytes. That means they allow the electric current to pass through it, because acids will produce H plus ions and bases will produce OH minus ions. Apart from that, both will produce positive and negative charges. That means they will conduct the electricity. So this is the circuit, and we have the two electrodes over here. So in between we have maintained the gap so that the current will not flow. But when I put inside the acid, you see here there is a glow of the bulb, that is proves that the acids are good conductor of electricity. Similarly, if I take the same setup into the base, you can see that there is again flow of current. That's the reason there is a bulb is glowing over here. But remember one important thing, that distilled water, sugar solution and alcohol are not good electrolytes. They will not conduct electricity. Why? Because they will not, alcohol and sugar will not dissociate in aqueous state to produce plus and minus ions, or cations or anions. So I have taken the distilled water over here, and let me, in this particular petri dish, I have taken the honey, that is the sugar. So when I put this electrodes dip inside the sugar solution, you can see there is no glow of bulb. That shows that the sugar is not a good electrolyte. Similarly, I have taken the spirit over here. Okay, so I am trying to dip inside the alcohol. So as I said, alcohols are not good conductor of electricity. You can see there is no flow of current as the bulb is not glowing. So these all are the activities which is given in the acid, bases and salts chapter. So finally, we have discussed all the, not discussed, experience learning happened in today's class, that we have done all the activities of the acid, basis and salt chapter. First, what we discuss about the litmus paper by dipping into the two of the solution. So when the solution is acidic in nature, the blue litmus paper change into a red color, and if it is basic solution, the red litmus paper change to blue in color. Then we did the we studied about the pH scale, and we used the pH paper and dipped inside the different solution, and we studied the pH value of the different solutions and all. And here we can see the beautiful colors over here. All we know what is the reason behind those colors and all. So this was a really interesting session, and this one is very very important diagram. This midterm exam, this particular diagram they are going to ask, that is the reaction of the zinc with the HCl, that is a pop sound diagram, or the liberation of the hydrogen gas we tested. And also we have tested for the liberation of the carbon dioxide gas. When the sodium carbonate reacted with the sulfuric acid, there was a liberation of the carbon dioxide gas, and we passed into the lime water. That particular lime water gave the white precipitate of the calcium carbonate. This also we discussed. And on excess passing of carbon dioxide, it will form the calcium hydrogen carbonate, that is the soluble in water. And conduction of electricity. Okay, we tested with the acid, we tested with the base, we tested with the sugar solution and the alcohol. And of course, distilled water also, there will be no flow of the electric current. So hope you enjoyed this session. If you really like, I think so this is the first time in YouTube somebody is uploading the video of the all the activities of the chapter which is being conducted in the laboratory. So if you really like this video, please do subscribe to my channel, hit the notification button, please like, and please give your feedback in the comment section. Till then, this is your Mahavir sir from the Mahavir Chain Academy. Jai Hind. Thank you one and all. Namaste.